Pointers are straightforward when the objects that you have a pointer to are just flat objects with no base class. So far you've seen pointers to integers, to person, to resource. When you have an inheritance hierarchy, then you have to understand the rules around pointers to a base class and pointers to a derived class. When you do an object-oriented design, you often use the test sentence ISA. So imagine a hierarchy where I have a base class bank account and some derived classes checking account and saving account. It's about a 30-year-old example, but it's a goodie. A checking account is a bank account. A savings account is a bank account. And if some function takes a bank account pointer, you can pass down a savings account pointer or a checking account pointer, and that function shouldn't complain in any way. It's a Liskov substitutability. In C++, it's done with pointers. The function takes a bank account pointer. I give it a checking account pointer. It thinks of it as a bank account pointer, stores it in that base class pointer, and then obviously calls only base class functions using the pointer. I haven't designed bank account, I just started talking about it, but imagine it's got get balance. That's a function in the base class. It will be in the derived classes. Both checking account and saving account will have a get balance, and so this code that expects a bank account pointer can go ahead and call get balance in total confidence. It's guaranteed to work. But a question arises, what code will run? In a lot of languages, you may think you know the answer. Oh, it's the more derived implementation in the subclass. In C++, it's up to the programmer. You decide when you write bank account whether get balance is virtual or not. If it's virtual, then the derived class version of the function will run. So saving account, get balance, or checking account, get balance. But if the author of bank account made get balance non-virtual, which is the default because it's the fastest, then only the bank account version will be executed, even when the object in question is really a savings account or really a checking account. You as the developer get to choose whether you want virtual functions or non-virtual functions. In C++, virtual functions are implemented through a virtual table, which is a little collection of memory that has the name of the function and where to find the code for it. You don't really care, and in fact the standard doesn't insist on it working this way, but the point is at runtime there's a little bit of a cost of figuring out what function to run. And your program is a little bit bigger because of the memory taken up by the virtual table. If your class has no virtual functions at all, it will be a little bit smaller and run a little faster. And in some cases, people want that. So you get to choose virtual or not virtual. Now, this relationship base and derived only works in one direction. So you can't take a bank account pointer and hand it to something that's expecting a checking account pointer. That's not fair. Checking accounts might have, overdraft limit, and your bank account doesn't have that. So a pointer to an actual bank account can only be given to code that's expecting an actual bank account, not to something expecting a checking account. But a pointer to a checking account can always be given to code expecting a bank account because a checking account is a bank account. Interestingly, when you use smart pointers, like shared pointer and unique pointer, you can get this same polymorphism preserved, exactly the same behavior as if you were using raw pointers. Since I consider using smart pointers to be a best practice, I want to make sure that you know you're not giving anything up when you use them in an inheritance hierarchy.